And we should be live. We are going to start in 3 minutes. The plan today is to have short live stream. Improve the thread pool that I called it some time ago, and it was actually just an re-implementation of some old thread pool, but improve the thread pool, then measure the STD thread. I kind of want to know how fast it's like to detach a thread, to do things like that. That's the plan. That's pretty much, I think, the plan. I think that's pretty much the plan. How can I make this close? What's this? I don't know, like measuring the STD thread pool should be, we could do it here in this. But I want to change a little bit the thread pool. Okay. So okay, let's start by improving the. Okay, so let's start by improving. Let me see. Yeah, let's just wait one more minute. Let's just. Then measuring the STD thread performance. I want to know how performant is the thread pool. Okay, that's pretty much it. Okay, so I'll close this. Okay, so I want to start first by moving this this definition here of a function should be should say, okay, this here is like std function void thread function, and we should kind of define this thread function to be this. Okay, now I don't want to make this anything in the here. I want a constructor where it will say min thread count and max thread count. So in min and max thread count will be, of course, two integers, min thread count and max thread count. Let's say that's 8 by default. Let's just do that. Max thread count. Now that thread function, of course, I will have. Of course, what I will do is I will say that for I can say this. Kind of min and max thread count. I could make a function also like reserve that will kind of change the thread count. While threads.size is smaller than min thread count, I kind of want into okay, this is a function, right? Okay, so I kind of want m threads and place back it's an std thread, but can just thread function be a constructor? I think it can. And this can be a construct. Oh no, I need to detach that thread, I think, right? No, I don't need, I just need to in place. So when thread is, wait, I have to read std thread detach. Yeah, but why is this std thread construct? What is the constructor of this? There's no detach here. There's just this worked, so. But I know that I have once coded with a detach. Why is this so slow? Come on. What's going on? In the structure of thread, std terminate is called if the thread was not joined, was not detached either. Thus, you should always either join or detach a thread before the flows of execution reaches the destructor. Yes, but if you construct it with an in place back, I want to know like the constructors, what does the constructors do? I want to kind of see if this makes any difference. Why is this CPP reference so fucking slow? Let's open some other reference. Yeah, oh, non-joinable. Yeah, of course, but we need joinability, right? This is detached just to like... Yeah, okay. So the thread, when it's created, it should be just thread of execution that can be executed concurrently with others in a multi-threading environment whilst sharing the same address space. Initially, a thread object, an active thread of execution. Such a thread is joinable and has unique thread ID. Default constructed non-initialized thread object is not joinable, and thread ID is common for all non-joinable threads. A joinable thread becomes not joinable if moved from, or if either join or attached are called on them. Moved from. And no, this is not moved from. Okay, we'll test out some things, but in theory this should work. And okay, so the thread here function will define the thread function. Now the thing is, okay, acquire job. Okay, we hold this thread from acquiring a job. This is when the job is executed. Then what if there's no like jobs execution? Job completion is 0. This was done if we want to notify if the job completion is 0. But one thread can like accidentally complete a job and then before the other threads can complete the job, can even sign a job. So what can happen is that one thread gets the first job, then there's no jobs in the thread pool, then like okay, complete. So how to deal with like knowing that all of these jobs have been completed? Maybe it's just saying that okay, with jobs in flight is like 0, and then when we call back here, we're not quite sure if there will be more jobs, which is a problem, which seems to be a problem. We can end the execution a little bit earlier than it's supposed to end. We kind of want maybe to not just add one job, but add many jobs, but no. How to deal with that fact? Well, when one job is done, okay, I don't know how to deal with that fact. Not sure. I don't know. Okay, so another thing is that, okay, so we have the minimum thread count and maximum thread count. We want kind of to reserve that. So what we can do is, okay, we build this thread function and we say, okay, we want to reserve min thread count. And this gets reserved. But then when I add a job and I say a job queue plus jobs in flight, I want to know if there is available thread. So the thing is that there should be wait, jobs in there should be std atomic int m jobs in progress and then jobs registered. Or jobs waiting, maybe is better. Okay, so then here when I move a job, I say jobs waiting minus. Because it's atomic, this doesn't really matter, right? So we do jobs waiting minus and then jobs in so then this job is finished. But here is like jobs in progress. Then here is jobs in progress minus. So if I have jobs in progress is 0 and jobs waiting is 0, if both of these is 0, maybe for just no, okay, this is faster. Okay, jobs in progress and jobs waiting. Then there is then when we say just a moment. And when we say that we want to add a job, jobs in jobs waiting is incremented in the queue, and we notify that this is an available job. When we want to notify that there is if mjobs, I don't know if like the equals operator is I think it's overloaded. If jobs waiting is 0 and jobs in progress is 0, then this is okay. I just notify this. Reserve I want to write all this like in jobs in progress and in jobs in waiting for both here. So this is jobs waiting and jobs in progress. We negate here job waiting, we add in progress, we negate in progress. Waiting is we add here waiting, there should not be any other changes to this. Okay, now the thing is when we add a job, we want to check if there is like more job waitings than when available job is notified. If there is still a job waiting to be done, but actually like if mjobs waiting is bigger than 0, but it's actually is bigger than 0 and threads smaller than max count, I can add a thread. I can add a thread. And I can notify all. Oh no, this I need to notify one because wait, I notify one is just unlocking yeah. Maybe here it would be created one more thread than what it is, but that's not a problem. That's not really a problem. Okay, so now where I create a thread pool is in the node graph. In the node graph, I will say, okay, minimum is 1, and then maximum is min thread count in max thread count, min thread count, max thread count. I can create this threading pool. I want to like measure this kind of creation. So what I will do is I will say platform instrumentation performance counter, and I will say that the name, the tag is like ThreadPool creation. And kind of, I don't need a table. Okay, so this is the creation of the thread pool. Now notify when all done is only like after I have added all of the jobs, which is kind of cool. This would not be thing here. Okay, so now I want to measure this the same way. Okay, and now I will build the software, should work fine, and we can now test this thread pool. Another thing I can do is I can open up Visual Studio Code. I can open up Visual Studio Code competitive. Here I just code some competitive programming tasks. But what I can do is I can kind of code just like let's open like measurements, and then let's open up like thread pool, and we'll kind of wanna this is not include chrono, and I want to see do I have like sleep? Yeah, I think I do have. So is it possible to just like, okay, let's try open up a thread here and let's just sleep for whatever. I don't know, is this in milliseconds or seconds? I have no clue. Let's open up a thread on that. And now I want to kind of just do std chrono high resolution clock. What was this now? And then at the end, and then auto duration is like, and std chrono duration cost, or duration something like end minus start, but then like this is std micro. Was it like this? Don't quite remember. std chrono duration. Duration cast. Duration cast chrono microseconds. I think this should be cool, and then I need to just kind of, what is this? I just need kind of to wait for the thread to join. Now if I go and if I say cd measurements and then I go ThreadPool TP02 and then is deprecated. What if it's deprecated? Is there a way to... Okay, it's a warning. I don't care. I don't really care about that. I only care... So 96, 97, what is this, microseconds to create this thread. And it kind of waits 1 second. So it's pretty inexpensive to create a thread. This is microseconds. If I have another end here where like I do that and I just wait for the thread to join. No, I did not compile the program. Yes, I should see exactly 1,000,000 microseconds. So this sleep is accurate. Okay, join a little bit waits for like there's some CPU cycles in between, but 90 microseconds to create a thread is like it's so inexpensive. And even to join the thread is like very inexpensive as far as I can see. So okay. So it's pretty inexpensive to create these threads. Let's just now roll up the node editor and measure some times when, like, what are going to be the actual times of the creation of these threads. Let me just go and okay, so we kind of have this thing here. If I now execute, this should all execute, and why didn't I get the oh no, it's not performance counter, it's scoped performance counter. We kind of screw that up. Okay. Performance counter has to have like stop and start. You have to call stop and start. Start and stop. This kind of counter you don't have. The scoped counter just what it does is just when it goes out of scope, it just stops. So it's like on the destructor itself. So that's why it should now fire. So we need to see like very fast creation of these threads. I don't know what is better to like. Oh, okay. Access violation. Where? when we in place a thread function, it does not mean that it becomes available immediately, right? And also threads, threads are very, very, the vector itself now just kind of, I need to reserve the vector. Hello. I need to reserve the vector, but I'm not even sure how should I wait for a thread to become to wake up, you know, because the thing is, creation of the thread is very fast, as we saw. Not this. As we saw, creation of the thread takes like microseconds. So, but the wake up maybe is in order of milliseconds. So how do we test what is the wake up of the thread is my question. Okay, so let's say that if I have an end here, clock, right? And I say, okay, auto end is like, okay, let's just do this. Auto thread wake up is this. Then I can say this. Okay, now I can give a capture to that thing. Now when the thread wakes up, we'll have this, and I can just say, okay, let's just say when the thread wakes up, the difference between when the thread wakes up and when the thread is started. So there's like not much difference from these kind of instructions here. So wake up. But I'm not sure because I'm measuring clocks from two different things, from one thread and from the other thread. I'm kind of not sure if this would make an issue. So it did wake up a little microseconds afterwards, but there's so much. So this is totally, huh. This is very small when the thread wakes up and when the thread is actually interesting. Very, very interesting. I kind of wait for this thread to join, so that there won't be any raise condition here on the thread wake up call. So this is very interesting. Let me just for simplicity, let's see, yeah, this is, oh, but this is minus start. Yeah, it's okay. So we kind of, okay, so we kind of know that it takes 160 microseconds to wake up, the thread to wake up, which is okay, but it's still way slower than what this job available will hit, because this function will create the thread, but job available is just not it's not it's not up yet. So when you kind of add a job for another thread, is it maybe just possible to wait like a millisecond or a microsecond? But still, like waiting, I don't like waiting, you know. I need to have like a mutex that locks this until this gets available, or maybe like just kind of says, okay, I'm here, like I'm running jobs available. Is it possible just to say I'm like how many threads are running right now? So like std atomic int atomic int threads running, and then but still I don't like when I now job available, wait for the lock if job queue is not empty or is not but I don't need to notify. Do I have to notify every time I kind of create threads? Is the question. Can I just... Yeah, thread running will be a nice addition to have, but kind of... Because you don't want to create many threads, but it's shared memory, so shared memory, it's a shared address space. Also, max thread count, we should add like a parameter. We should add like a parameter for a max thread count on the notator itself. So the thread pool is just essentially like where like the threads exist, and now then like you send jobs to for the threads, and then the thread that is not doing anything just takes the job. The first thread that like comes through the queue takes the job, okay, says okay, thank you, and then it just and we of course lock the queue, so any other thread should not take the same job. But that's not the problem. The problem is that there's microseconds here in question. It still fails. And where does it fail? On execution of nodes. No, I think this way of like in placing threads changes the pointers or something. I don't know. No, it shouldn't change the references. There's like all of these are movable. What I will try is when I reserve here minimum, I want to also kind of say, okay, threads dot reserve max thread count, and now this should allow me to have the vector always here, regardless of this. But if I in place more threads, it does not mean that there should be any problems here. It's just like I'm emplacing threads. Should be fine. Should be fine. Job available. Okay, so it was the problem of like the vector reinitialization. Or something else. Entirely. Oh, on the distractor? On the oh, interesting. I think that's the destruct. Yeah, thread.join. So it was a problem on like some thread.join thing. Detach join, no such process. Oh, no such process. What? That's kind of weird. If it is joinable, then yeah, that's kind of weird. Oh, is it possible that the destructor here notify all takes time to wake up all of the threads? But this is maybe faster. And just completely wakes up all the threads, shuts them down. But maybe in the same time this is shut down, this thread is... To be honest, I don't think we need this. I don't think we need this, to be honest. Because when we notify that there is some available job, each thread will say, okay, job is available, we'll notify all. And now we say, okay, no, it's no longer running. If it's no longer running and the job queue is empty, then we should kind of say that, okay, so I will say mjob queue clear. Is there not no clear command on the queue? Oh my god, std. Not empty, then like... But no, this is not running, and then we notify all. What if there is a process that the queue is not empty, right? So, okay, the queue is not empty. In this case, this is moved, this thing here. But we should wait for this. Hence, all of these are... The thing is between this and this. Is there atomic joinability? Here, no. Because I don't... Because you can have some things here. Multi-threading is always a pain, but just... multi-threading is always a pain, but I don't know. It's just if it's joinable, and now it seems that it's not joinable. There's no such process. Weird. Absolutely weird. I don't know why would that be. But it seems in placing threads now has huge issues. This is a trade-off. Do we want something that works, that just creates 8 threads regardless? Or maybe what we can do is find the longest anti-chain on the graph, and then always reserve this many threads on the longest anti-chain, and then, or maximum count, I don't know, 8. And then when I reserve 4 on the anti-chain, then I know that at most 4 will be reserved. When I place here a function, it is so fast, and then another function what I can do maybe, yeah, this in places all of the threads here, and then what it does is that, okay, most of them are locked. Yeah, this is not a good idea. This is not a good idea. Maybe the better idea is jobs waiting. For jobs waiting. And for this, in place all of the threads, and threads dot size is smaller than max thread count. Now that they're all in place, oh, what happens if you add a job, but then you destroy the thread pool? I wanna see. Oh, this is the problem. No, this is not the problem right now, but this can be a problem. Right now the problem is that, okay, we have some threads that should be oh, they're all shut down, that it's not running. Not running, but we do not notify. This is a problem. We want to notify all that is not running anymore. And now also the job queue, we should maybe we should remove all of the jobs from the job queue if it's shut down process. Or no, maybe not. Maybe just notify all. But so I think this is fine. Give me just one moment. So I think this is fine. We'll see. On the thread count, dynamic ThreadPool C++. So we kind of run that. That works. And then if I run again, that works. But now it doesn't. We made it a lot unstable with this here, and I don't like that. Add a row table, add a row performance counter dot stop. Now it seems that M data is accessed quite a bit. Oh, this is the same table. Yes, this is the same table. Oh, I need to implement a kind of concurrent performance counter, because I'm accessing the same table, and this is just this kind of this is too fast. This is too fast and kind of violates all the things. Okay, so perflog. How do I? Okay, so I need a mutex on the table. Concurrent. Do I implement like a concurrent table where? But no, then I have to deal with all this garbage, all these functions. I have to just implement an access to that table. I can just do in the node editor itself. I can do that. I can say in the node graph execute node. I can say the following. I can have a mutex that will the performance table. I will put it here, table that stores this, and then I will have like a std mutex performance table mutex. And now I can I can go into execute node. I can see where the table, the scoped performance logs are, and I will say this is on destruction, so it's only writing on the table on destruction. So I kind of want a performance counter where I start the performance counter from here, and I say there is start procedure, or I can just do that. Then I say I kind of lock this std unique lock std mutex, and then lock is this performance mutex, and then I say performance dot counter Then I say counter dot stop, and this should kind of just write to the table, and that should be fine. Counter dot stop. The unscoped performance counter does not have a, so that should be fine, right to the performance table. Yeah, that should be fine. Now this is concurrent. Concurrency, when you're dealing with concurrency and with multi-threading, you have to take into account everything when you're writing to the same object. So like every time you write to the same object, you have to take into account that, okay, there could be multiple threads writing to the same object at the same time. So this is very, very important. I want to just kind of get a little bit more light while we're waiting for this to build up. Okay, now I can just try here and see. Let's open up here. Oof. Yes, this is something. CPU time. But I don't know why now this takes so much time. Okay, so let's imagine let's just ThreadPool creation is 0 milliseconds, just 26,000 CPU cycles. So very fast. But somehow this is now slower. Somehow this looks now slower. No, why this many cycles? But it does use more, it does use the CPU, like the threads, but why is this many cycles? $1,600 milliseconds. So 1.6 seconds. I think 1.6 seconds. And yeah, you see something failed here. But if I go, okay, so let's just assume, okay, I don't know what we did. Let's go to the platform, let's go threading, let's open up a new branch, ThreadPool. Let's go here, let's go improve ThreadPool. I want to kind of see how much was it prior to that. Okay, so I'm gonna return back to the ThreadPool. I'm going to go here and going to go new branch. Okay, let's not do a new branch. I'll just check out the commit. Improve thread pool. I want to see something. I want to see, okay, so let's go back to check out this commit. Check out commit. Now I want to rebuild that. I want to rebuild that. Could it be possible that not having this I don't know, this destructor is kind of broken, I think. I want to see an examples of some dynamic thread pools. Also, I want to kind of see this destruction of a thread pool. How to properly destruct the thread pool. Yeah, pjoin. I mean, I'm doing that, but hardware concurrency is like the number of threads it has. So yeah, an infinite loop. This is exactly what we're doing. Blah blah blah. And then there's some like binding. Okay, so this is like the move operator. This is very nice library. Okay, so libraries. Okay, let's say the dynamic thread pool. What is this work thread test usage? These are examples. Include dynamic thread pool, worker thread pool. Worker thread pool, fix may change, return value to STD future. Yeah, STD futures are also nice. Maybe someday to support them. Worker thread. Worker thread. Okay, so we go here. We import that. Import the graph. Okay, and we go plop. Okay, 1.5 seconds. So a little bit faster. .6 seconds. So it wasn't that faster. So it was about 100 milliseconds. 3 million, 3.2 million. Is it 3.2 million? No, it's 300 million CPU cycles. It's 300 million CPU cycles. Yeah, okay, that makes kind of sense. About 100 milliseconds. And 1600. We kind of need to do a little bit more measurements on the thing on like 1600. We can more measurements and then do like standard deviation and all this kind this 1600 sometimes it breaks more, but okay, so like standard deviation would make, but yeah, so we use around 50% of all processors at peak time. So now that we stop this, we go and we say okay, let me just go to the platform. Okay, improve thread pool, and now go to this. Of course, I don't know why it never caught the performance table. And now here when we improve the thread pool, now all of a sudden the performance table gets incredibly important, which is very interesting. But okay, this will be pretty much kind of short live stream for today, because I just wanted to see how the thread pool functions. But we have to make I mean, I will kind of read a little bit on and make environment where we can really test the limits to the thread pool itself, and then really test all of the limits and find all of the bugs for the thread pool, because this is not an easy thing to measure and to deal with. Multi-threading, when you have multi-threading, all of the access to memory has to be guaranteed, that like you're not racing, that the threads actually access the memory in a very specific way, with mutexes and all these locking mechanisms. Now C++ allows you to do these easy locking mechanisms, but I want to kind of stress test a little bit to see like if it would crash, if there's a need for improvement, so like now here the thread pool kind of has the same parameters, 1.5 milliseconds, 1.66, 1.55, 1.6 seconds, 1.6, and now there is a race condition. But why? Could it be... Okay, before shutting down the threads, I will say I can try this before execute maybe this. Before I'm creating a new thread, I want to see thread pool dot get current thread size. I want to add a function, std get current thread count. There should be a const function. It's faster to implement this kind of thread pool current and threads size. Of course, now this function is not safe in race conditions, but stupid. But it should help us kind of see if thread size gets larger or just remains the same. Thread pool, and I want to log that onto the thread count from previous execution. I want kind of to log that info just to see if there's more thread or more threads than every time if they get bigger or actually smaller, or what actually happens here, you know. The thing is, I think that this structure here somehow just makes our life a lot harder, because Well, okay, M running is an atomic, so I don't have to lock the QMutex here. I can just say M running is false. I can notify all of these. But I don't think they wake up immediately. But maybe some of them wake up immediately and some of them don't, and then there is like this kind of, if something, what is joinable, what is joinability, you know? Thread joinable, and how to use that properly. Okay, so we start a thread and it says, okay, it's before starting a thread joinable. Okay, after starting a thread, okay, so we gave some function that is joinable. After joining, it's not joinable, and then when if it's detached, it's not joinable as well. It just checks if the thread object identifies an active thread of execution specifically returns true if get ID is not equal to the STD thread ID, so the default constructor is not joinable. Yeah, default constructor is just what is this now? The link proper. Okay, so this is the only thing that it kind of scares. I mean, does conditional variable wait, if I have std conditional variable and I call wait here, does it actually wait immediately? Oh, what am I doing? Of course, I even thought about that. Of course it is a null pointer from the beginning. I'm curious about something like that. std conditional variable wait function. Wait causes the current thread to block until the conditional variable is notified or a spiritual wake up occurs. Thread can be to the text atomically calls unlock and blocks on equivalent. Okay, so how many threads were at execution time? Okay, now there weren't, of course, because here. Now there were thread count from previous execution 7. 7 threads. It's kind of weird. Okay, again 7. Then it crashes. But why 7 counts? 7 threads. Jobs waiting. For the jobs waiting. Jobs waiting cannot be 7 jobs waiting. What? There's no way to be 7 jobs waiting. And thread.size is max thread count. Okay, so I'm not certain why would that be it, but there is just a way that there's no like joinability here. I mean, this crashes. It is joinable, and then when we say join, it's no longer joinable. It's very weird. Say it is joinable, and that's no longer joinable. Wait causes the previous version block right after wait returns is true. Lock metrics is locked by the calling thread. When unblock calls, possibly unlocking then returns fail. Wait for, wait until, wait. The effects of notify one or notify all, and each of the three take place in a single total order can be used as modification order of an atomic variable. The order is specific to this individual condition variable. This makes it impossible for notify one to, for example, be delayed and unblock a thread that started waiting just after the call to notify one was made. Okay, I'm not sure. I will be going into depth here a little bit more. For now, what I can say is that, wait, if I now limit the thread count, now here is the problem. It's like m threads has 7 threads, which is kind of weird. It's not even close to, but the threads are so inexpensive to create that I'm kind of thinking that I don't even need to do that. So I'm kind of thinking, okay, let's amend this. I mean, jobs waiting, I kind of like that. Jobs waiting, jobs. But I will be right back now here. I just a moment, so So let me think about this. So jobs waiting and jobs here, the only thing jobs waiting is jobs progress just indicates this. I want to reproduce this issue. Okay, let's try to reproduce this issue. Let's go to the master branch. Let's go, okay, so let's say that I don't care about this this idea. Okay, I care about this. I don't care about, I just have to change the older to the older thing here, where 8 was the was this given, and also 1.8 was here. Okay, so let's kind of reproduce this issue. Try to reproduce this issue of trying to declare a local variable. Yeah, with no name. I mean, performance counter, and then let me just avoid the warnings. So let me reproduce this issue. The issue that I'm seeing is the just joinability. So threading.cpp, when we clear this is now the issue as far as I see. They can't be joined. The callback here is running, then this is shuts down, this shuts down, this shuts down, and of course they can't be joined because it's already shut down. Oh, I think the problem is that I'm not notifying. I can recreate this issue by notifying the threads here of the shutdown. And then this is joined. Okay, so I think I can face this issue. Just add a if statement that if it's running down, then this is the threads. But I don't see how a thread can be joinable at the same time and then not join. It's kind of weird, which is absolutely weird. Let me try to recreate this issue. Okay, let's. I cannot recreate this issue. Yeah, of course I cannot recreate this issue here because I'm not even shutting down the threads. Let's say that I am shutting down the thread. So job available notify all. And now that I am shutting down I am actually shutting down the threads, then I should see the issue in the things. Okay. So this is nice. I think we'll be finishing the live stream a little bit in like 5 or 10 minutes after just doing this and just pushing and seeing if that works, and maybe even pushing it on master. I don't know if I will push it on master right now. I'll see, because this actually works pretty well without the dynamic threads, but we'll see. Stupid. Okay, so let's just. I think now I can recreate the issue. after some attempts. Maybe. $1.54, 1.52. It's very consistent. Let me try. I cannot recreate, okay, by this. So jobs running this. So shut down. It is triggered here, and I would guess that this makes them. But it's not triggered, so this exception is not triggered at all. What else was changed even here on this platform? What else was changed? Okay, so this function, we added these things. We added the notify here. We added this. Maybe it's just it's a little bit. Maybe it's not this. Maybe it's not this. Maybe running call doesn't even matter, because if this is spiritually awakened or whatever it's called, it's not even. It just checks. It could check M running. It's prior to notify, so I think won't be the issue. It's not triggering at all. Unbelievable. I don't need here Q, I can just say it's running false. Then I can say notify all and then join. This emplacement of vectors is not good. It could be due to the notify when done function. Also. 1.6 seconds, 1.6 seconds, 1.6 seconds, 1.6 seconds, 0.56 seconds, 6 seconds, 6 seconds. 6 seconds. I don't know. I think we should do more experiments on this before actually committing to some kind of thread pool. I think we should fix the issues with the table. And in the sense of that, okay, this is a table that stores so here the performance counter on the thread pool creation, I think it was pretty small, right? So every time I created a thread pool, it was, oh, here it's like 2 milliseconds, 2.5 milliseconds, 1.6 milliseconds, 1.0 milliseconds, 1.1. Yeah, 8 threads times times like 100 microseconds per thread of creation. Then that would assume that, yeah, 0.8, but times 1.5, maybe 1 millisecond that you have to create the thread pool itself. The threads are not even waked up, but the threads are not even, but 1 milliseconds, it's nothing in comparison to the graph execution times where JIT optimization is even like, I mean, no, but in some cases it's a lot, but I think for now, I think it should be fine. But as long as this shuts down, okay, like mThreadPool shut down, but what if I do mThreadPool is null pointer? I'm curious about that, because now you actually dereference that. I don't know. Would that work or would that not work? Because I really want the thread pool to be a null pointer when the graph is not executed, because there's no need the threads to be like waiting when the graph is just in idle mode. So that should be null pointer. But I don't know if that lambda context then falls apart. Or if, but this is posted, right? This is on the UI. Ugh, I mean, whatever. Let the debug be open. So I'm kind of 1.7 seconds. 1.7 seconds. 1.7. Is the debug making it that slow or what? 1.7 seconds. 1.78 seconds. Or are the threads not? but okay, it's 1.7 seconds. .75 seconds. 1.68. Okay, one last time we experiment with this. 1.5. Now it's faster. 1.6. 1.6. 1.6. Okay, so now I can say with confidently, I mean with some like 80% confidence, that this is a better thing to do. What was the measurement on the time creation of the pool set? 2.5 seconds, 2.5 milliseconds, 1 millisecond. Okay, around that. So do we leave the scope performance counter on the creation? Yeah, why not? Instead of shutdown, we do null pointer and we say, okay, let's thread shutdown shut. Just to be sure, we're gonna dereference the pointer, and this should shut down the thing. Okay, this should shut down both. This is the creation and the performance. Lock performance table when properly manage when multi-threading. Three milliseconds to just create the thread pool. 2 milliseconds. I mean, that's nothing. That's nothing. It should be fine. Yeah, you see the difference between this peak and this peak. And the memory consumption. Okay. Okay, I think should be fine. I don't think this should be fine. This should be fine. Okay, nice. Alright, that's I think it. I won't do it. It's just so little to do it dynamically for now. It doesn't seem worth it to do it dynamically on the thread pool. What? I think it's fine. So yeah, that's pretty much it. I don't know. Okay, let's say shut down. Shut down. Let's measure this performance between the the end and the duration here. So between the duration here and thread shutdown. Let's measure this performance. See how much does it take. This is shutdown. If this is my 130 microseconds, so probably practically nothing. Practically nothing in the way that, okay, we're dealing with parallelization where we have parallelization on millisecond level. So this can be improved. So if we're doing with this, if we're dealing with this kind of parallelization on this microsecond level, then yes, threading won't be really an option there. But here it's okay. Here it's okay. For us, at least for now. So this should be fine. The next stream is going to be more on probably what it leaves. Oh, it probably leaves the just-in-time, like a little bit of performance juggling. Like, how should we use these performance counters to our advantage? But it's very hard to measure this unless we make some synthetic graphs, which should be our next thing. Also more debug information, and maybe we should go and improve the rendering engine. I kind of want to improve the rendering engine now, but I don't, because the rendering engine has some things to be improved. Maybe we should play now a little bit about the rendering engine, but how much? No, we shouldn't. Let's improve the rendering engine on the next stream. This should be fine right now. Okay, thank you guys so much for watching, and on the next stream we will improve a little bit about the rendering engine and maybe some few more stuff in the node editor. Thank you guys so much for watching, and I'll see you in the next stream.